Hey everybody, so in this video we're talking about factoring by grouping. So you would use this typically when you have four terms. That's always going to be your first method of approach, and factoring by grouping is incredibly simple. So all we're really going to do is just group the first two and the last two, and we'll create our own binomial. And within each binomial, what we're going to look for is the greatest common factor. Remember, that never goes away. We're always looking for the greatest common factor, so that's what we're going to use here. So if I look at my first one, x cubed and x squared, or excuse me, x cubed plus 4x squared, my greatest common factor is going to be x squared. So I will write that here. Now, remember, when you factor, that is synonymous with division. So here there are three x's. I took two of them out. That means there is one x left. There were two here. I took them out. None left. If you think about going through and dividing, x cubed divided by x squared leaves you with an x. 4x squared divided by x squared just leaves us with 4. Lastly, right here, I have 8x plus 32. I can't factor out an x because this term of 32 does not have one. So I look for the largest number that can go into 8 and 32, and that is going to be 8. And I am left with 8 divided by 8 is going to give me just the x. 32 divided by 8 is going to give me 4. Now, what you should notice is that this binomial should be identical to this binomial. Now, the reason I say that is very important, because we're actually going to look at this and pull out the greatest common factor. So you may be looking at this like, wait, what? What's the greatest common factor if I'm looking at this? Well, it's going to be the x plus 4. This x plus 4 and this x plus 4. Now, over here, I'm going to give a little example. Imagine if this were x squared y plus 8y. And I said, look at this. What's the greatest common factor? Well, that's really easy to say, oh, well, that's y. You would just factor out a y and be left with x squared plus 8. Well, all I'm really doing is I'm replacing y, or here in this example, it's not y, it's not one term, it's a binomial. There is a greatest common factor. It just so happens to be a binomial of x plus 4. So I'm going to factor that out. And what I'm left with is what remains, x squared plus 8. And here, this would be the factored form of this polynomial. And that's really all you do. The big thing is you're just getting accustomed to thinking that greatest common factors can be one term, monomials. They can also be two terms, binomials. So let's try the same thing with this example in the middle. We'll group the first two. We'll group the last two. Here, I'm pulling out the greatest common factor. Well, that looks like it's going to be w squared. So we have that. So that leaves me with w plus 5. Now, again, whatever you factor out, you want what remains to be identical to this. So here you have two negative numbers. Well, how are you going to make them positive? Well, I'm probably going to need to factor out a negative number. So here I would factor out 8. Now divide everything by negative 8, and that would leave me with w plus 5. Now again, you're not done. You're looking at this and you're saying, what's the greatest common factor? And that's going to be the w plus 5. So here we're going to take this w plus 5 and this w plus 5, and we're going to factor that out as well. And we're left with w plus 5, and we have w squared minus 8. Now, when you get here, you're technically not done unless you cannot factor again. Can this be factored? Is this a difference of two squares? Well, w squared is a perfect square, but is 8 a perfect square? It is not. So we technically are finished here. We can say that this is our completely factored form of this polynomial. Last example, we will group the first two and the last two. So here there's no number, so I can only factor out a p, and you have to factor out the smaller one. So I'm going to factor out p cubed, and I'll be left with p squared minus 6 And again, whatever I factor out, I want what remains to be identical to this. So I need a positive p squared, a negative 6. Here, this is a negative 2p squared. So I'm going to factor out a negative 2 so that the p squared becomes positive and the 6 that remains becomes negative. So now I will pull out the common factor of p squared minus 6. So here we have p squared minus 6. And what is left is p cubed minus 2. Now, is this a perfect square? No, because 6 is not a perfect square. And this is not factorable. So, that's going to be it for these. Let's take a look at just a few more. What if it's a little bit harder than just grouping the first two and the last two? With these examples, they tell us to factor by grouping, but we were going to need to rearrange the terms first. Now, here's when you know you're going to need to rearrange the terms. What if I go ahead and group the first two and the last two, and I try to GCF? Here, it looks like I can pull out an x, so I'm left with 2y plus 5, and I factor out, say, a negative, well, I can only factor out a negative 1, and that will leave me with x squared plus 10y. Are these two binomials identical? They are not. Okay, so factor by grouping does not work now because the factors are not, you're not going to say, oh, well, the answer is just x minus 1, 2y plus 5, and x squared plus 10y. That's not the answer, because if we multiplied all of this together, we're not going to get this. We're going to get something totally different. So these are not the factors. So we got to go back and rethink this. So that's a real easy way. Just look at it. And if I group the first two and the last two, if the binomials are not the same, you're going to have to rearrange your terms. So let's think about this. We have a 2xy, and we have a 5x, an x squared, and a negative 10y. Okay, well, you're not really going to be able to reduce 2, okay? So let's think. What if I rearranged it so that I had 2xy and the x squared together? That way I could factor out an x from each of these. And the reason I say that is because if I put the 5 with the 10 and factored out a 5, that would create another 2. So here, let's say if I said plus 5x minus 10y. Now let's try to group the first two and the last two and see what we get. Here I can factor out an x, and I'm left with 2y minus x. Now here, let's try to factor out we'll factor out a negative 5, and that leaves us with negative x plus 2y. So here we really have the same thing. Even though they don't look identical, you can just rearrange. Negative x plus 2y is the same thing as 2y minus x. So we can factor that out. So now we have 2y minus x, and what is left over is the x minus 5. Now, sometimes this can be tricky, and unfortunately, this will be one of the few times you really have to use the guess and check, even though I hate using that because there always should be one specific way to get the right answer. I'm a firm believer in that. Sometimes, really, until you kind of get accustomed to this and you recognize the tricks and you kind of know what to pair with what term in order to factor, it's just going to take some practice. So I'm telling you, you have to rearrange. So don't leave it in this order, okay? So looking here, we have an m squared, an m, and a 7n. Okay, so here's what I'm thinking. I'm thinking we should pair the 12m squared and the 3m together because I can pull out a 3 from both. I can pull out an m from both. I like 28mn and 7n being together because I can factor out the 7 and an n. So let's try that. 12m squared plus 3m plus 28mn plus 7n. All right, let's pair our first two and our last two. My greatest common factor here could be a 3m. And that's going to leave me with 4m plus 1. Here I could factor out a 7n. And that would leave me with 4m plus 1. And now I have a greatest common factor of 4m plus 1. And what is left is 3m plus 7n. Now, we don't have to worry about the excessive use of the variables, okay? Because here we have lots of variable usage in our polynomial. As long as you can arrange them and group them so that you have matching binomials, the factor by grouping is going to work. All right? Let's look at our last example. So you can pause the video and you can try this last one. See if you can group them so that you can have a greatest common factor with each pair. All right, so I hope that we get the same answer here. So here's what I am thinking. I like 10ab with 15a because I can factor out a 5 and an a from both. And I like 21 and 14b because I can factor out a 7 from each of these. So let's see what we get. So here I have 10ab minus 15a plus 21 minus 14b. I'm going to pair the first two and the last two. Here we said we could factor out a 5a, and that leaves us with 2b minus 3. So I need a positive 2b and I need a negative 3 here. That was positive. So here it looks like I could factor out a negative 7. And that would leave me with a negative 3 plus 2b. And remember here, even though they look different, these are identical. See how the 2b is positive and that 2b is positive? This 3 is negative and this 3 is negative. They're the same thing. So I can factor those out. And that will give me 2b minus 3. And what is left is 5a minus 7. All right, so I know these can be a little confusing. It will take practice rearranging them and factoring out so that you have like binomials. But after a while, you will kind of start to see the pattern and you'll be able to do this kind of in your head. Like, oh, I know if I pair these, I could pull out this greatest common factor. And if I paired these two together, I could have this common factor. So let's give that a shot. All right, that's going to be all for this video. I hope that you found it helpful. If you have any questions, please leave them in the comments and we'll see you all in the next video.